All right, so let's add in our controls. So let's add in an override function. And by the way, I just highlighted and deleted the touches began here. So we're going to add the override function, and we'll call this touches moved. Now, touches moved will get called every time you drag your finger. And in here, we have to add in a for loop. We'll say for touch in touches, right? And we'll say, in here, we'll say drag touch location, which is that variable we set up. All right. Drag is equal to touch dot location in node, and it'll be self. So we now have a global variable to take a look at the nodes here, and it will store that data within the touch location. Okay, and within here, let's add in another function here. We'll call this function move player, and we might as well do on touch as well. And we'll call move player on touch. Now, I like to do it this way where I set up my own function for it, because if there's another reason we need to move the player on touch, we can call it then. But for now, let's go ahead and let's add in the items here. So we're going to say if is alive is double equal to true. Okay, we'll only be able to move the player is alive here. We'll say player dot position dot x is equal to. Now, this is what I like to do personally. I'm going to type in some code that's incorrect, and I'm just going to have Xcode fix it. I personally like to work this way. So the correct code is this. It says touch location, or drag touch location dot x, and then an exclamation point. This is the correct code. But the way I like to do it is this. Drag touch location dot x, and then it's going to come up with an error and fix it. That's just my personal way of doing that, because I know exactly what I want, and it's the touch location of the X. So all we're going to do is we're going to do the touch location of the X here. And Xcode wants you to fix it, and Swift constantly updates itself. So that is something that you need to understand, is that sometimes you might be doing something that's similar, then you'll need to fix it. In fact, I had this one project that I made in Swift 1, and when I opened it up in Swift 2, there was like 167 errors, and I had to fix all those errors. So just keep in mind that that's part of programming. Okay, so is alive is double equal to false, and if is alive is equal to false, we're going to set player dot position dot x is equal to negative 200. Now, what this does is it moves the player right off the screen. And you're thinking, well, why would we need to do that? Well, the reason is that a lot of early mobile games, instead of actually destroying and creating objects, they just moved them off screen. And that may sound silly, but you have to remember that early mobile devices didn't have a lot of power, and they weren't very powerful from a computing power point of view. So creating and destroying actually uses up more power, so they could actually reduce lag this way. So that's kind of neat. So that's we've now set up our move player on touch here, but we need to spawn a player. So let's add in our function called the spawn player here, and we'll spawn the player, and we'll say player is equal to sk sprite node, and we'll make it our color here, and the color will be off white color, and the size will be player size. Okay, and if you want to, you can always go player dot size is equal to player size. Okay, and that's in case you want to add in your own art. So we'll set the size. In this case, it's a bit redundant, but there is no SK sprite node which just takes in the color. It has to take in the color and the size here. So we're going to say player dot, and then we're going to say position is equal to CG point, and we'll add in a point here. We'll say that this is CG rect get mid x self dot frame, and then it's going to be and then the y here we'll just set at 120. Okay. Then what we're going to do is we're going to add in our physics bodies. So we're going to go to player dot physics physics body dot is equal to sk physics body, and we're going to do rectangle of size, and we're going to go to player dot size. And again, this will ask you to fix it. It's my personal favorite way of doing that. Okay, and we're going to go to player dot physics body is dot affected by gravity is equal to false. Player dot physics body dot allows rotation is equal to false. The reason is that if you allow rotation, then your player will rotate to different angles. So we're going to say allows rotation is equal to false. Then we're going to add in player dot physics body, and this is where stuff gets a little bit complicated. Dot category bit mask. So when two physics bodies collide, they compare the category bit mask. So imagine if you had a ball and a wall, and you threw that ball against the wall. Well, the ball would be to the computer 0 and the wall would be 1. So to the computer, it's 0 colliding with 1. That's what we're doing here. It's an abstract way of adding in collisions. Okay, so we have our category bit mask here, and our category bit mask is going to be physics category. That struct we set up dot, well, player. Then we're going to add in player dot physics body dot contact test bitmask is equal to physics category dot, and then what we're going to say here is dark block. Okay, pretty cool. And we're going to say player dot physics body dot dynamic is equal to false. We're going to go to player dot name is equal to player name, and we need to add in this player name because it's now a string that we can compare. Okay, and then last we need to go to self.addChild, and we're going to add in the player. Okay, so we've now set up the player and the controls. In the next tutorial, we'll continue on setting up more objects.